2022 Grade 7 Gauss Math Contest, questions 21 through 25. Square ABCD is divided into 4 identical smaller squares, which are further divided into triangles, as shown. What fraction of ABCD is shaded? What we can do is we can cut them all into 4s, so like that basically. And then how many of these triangles do we have? Like, for example, this is one, right here, this is one triangle. Well, there's basically 4 in each of those squares, so there's 16 total. Now we gotta count the shaded ones. Well, there's 1, 2, 3, 4, 5, 6, and 7. And that's it. That's pretty much how you do this. So the answer is C. In the list P, Q, R, S, T, U, V, W, each letter represents a positive integer. The sum of the values of each group of 4 consecutive letters in the list is 35. If Q plus V is 14, the largest possible value of P is. So we have P plus Q plus R plus S plus T plus U plus V plus W. And they're saying that each of these is 35. The sum of 4 consecutive. So that would also be 35, and that would also be 35, and so on, right? You get the point. And then they give us this little clue here, and they're saying, what's the largest possible value of P? Okay. Well, interesting. Well, these 4 total 35, and these 4 will also total 35. So the total of all 8 letters would be 70. Okay. So far, so good. And then any 4 consecutive letters would be 35, right? So, for example, these 4 would also be 35. So I can use that. So I'll just put P, Q. I'll put 35 for those 4, and then V plus W. And then that's 70. And then Q plus V I'll group together. And then I will put, so that takes care of the Q and the V. I'll put the P and the W here. And then that's going to be 35 when you bring the 35 over to the other side. Q plus V, they told me, is 14. So that means I've narrowed it down to 2 variables. So that means P plus W is 21. Now they're saying all of these are what? Positive integers, right? So we want P to be as large as possible. So we will make W as small as possible. So we'll make W a 1. And therefore P would be 20. And I think that is it. P has to be at least 20. Can't be, because W has to be a positive integer, right? W can't be 0 or negative. So the smallest we can make W is 1. And when we do make that a 1, P becomes 20. So I think that's pretty much all there is. So C is the answer. Question number 23. Ishari places the letters A, B, C, D, E, F clockwise around a circle, starting with A at the top. Jackson writes a list beginning with A, and then moving clockwise around the circle, writes down every 3rd letter that he has not yet written. Doing this, Jackson's list is A, D, B, F, C, E. Katerina mixes up the letters L, M, N, O, P, Q, R, S, and places them in the mixed up order around the circle, starting with L at the top. Jackson writes a list beginning with L, and then again moving clockwise around the circle, writes down every 3rd letter that he has not written. Jackson's list is L, M, N, O, P, Q, R, S. Starting with L, what was Katerina's clockwise order? Okay, so first I've got to explain this question, and then we'll attempt it. So the first part of the question is just telling you what is happening. So A, B, C, D, E, F, right? This is Ishari. And then Jackson comes into the game or whatever they're doing, and then he puts every 3rd letter. So he starts with A, right? Beginning with A. Yeah, it starts with A, but then he puts every 3rd letter. Okay, so let's count this. Every 3rd letter. 1, 2, 3. So the next one would be D. Got it? Then every third letter, 1, 2, 3. The next one would be B. Every third letter that has not been written yet. So you got to jump over the ones they've already done. So B is done. And then every third letter, C, E, F. So the next one is going to be F. F is gone. Next third letter, C, E, back to C. And then there's only E left, so obviously that's the only thing. So that's the order A, D, B, F, C, E. So I hope you kind of understand the process, right? So we have to do the same process, but this time with Katerina, her letters. Now, they only told us that she starts with an L. Katerina mixes up the letters, and then starting with an L. Right. Okay, so there's Katerina. So she starts with an L. Now, the other letters we don't know, but they do tell us that Jackson, his is in that order. Okay, so I guess what they're doing sort of the backward. They're giving, in the first part, they gave us this and told us to figure out this. Now they're giving us this and telling us to figure out that. Okay, so that shouldn't be too bad. So L, M, N, O, P, Q, R, and S. So basically alphabetical order. Okay, so let's figure this out. Oh boy. So this one is given. So the next one is M. So the M would have been the third letter. So let's say this is the first, this is the second, this would have been the third. Got it? Okay, so the next letter is N. So this would have been the next letter, and then the N. Okay, and then how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. And how many do I have? 1, 2, 3, 4, 5, 6, 7. So I've got another one here. Okay. So L, M, and N are already placed. So those are ones we have to jump over. Next one is O. So 1, 2, 3. So the O goes there. So O goes in there. Next one is P. So 1, 2, 3. So the P goes up here. Next one is Q. So 1, 2, 3. Q goes here. Hopefully I haven't made any mistakes. R is next. So 1, 2, and then 3 again. So R here. And then finally the S goes there. So L, R, O, M, S, Q, N, P. L, R, O, M, S, N, Q. Oh, this one right here. Got it? Okay, so that was not too bad. Number 24. A palindrome is a positive integer whose digits are the same when read forwards or backwards. For example, 3, 2, 5, 2, 3 is a palindrome. How many palindromes greater than 10,000 and less than 100,000 are multiples of 18? All right, well, we are going to use some divisibility rules. So we have this range that it's greater than 10,000 but less than 100,000. So the numbers are all 5-digit numbers, right? Because if it's greater than 10,000, it's at least 10,001. And the P for palindrome. And if it's less than 100,000, it's got to be at least 99999, right? So, I think, yeah. So they're all 5-digit numbers. So we're going to call these letters, we're going to call these digits by letters. So A, B, C, but it's a palindrome. So this has got to be B, this has got to be A, right? Because whatever is written forward is the same as it being written backward. That's the definition of a palindrome. Now they tell us that they want only multiples of 18. Okay, so some of you have these memorized, but some of you don't. Divisibility rules. A lot of I's in that word. Divisibility rules. And I'm going to talk about two. So they're saying that they want multiples of 18. If something is a multiple of 18, then it's a multiple of 2, and it's a multiple of 9, correct? For example, 36 is a multiple of 18, but it's also a multiple of 2 and a multiple of 9. If something is a multiple of 2, that pretty much means that the number is even. If something is a multiple of 9, there is a divisibility rule, and it states that the sum of the digits of that number will also be divisible by 9. And that is the key to this question, in my opinion. That is the divisibility rule that will help you solve this question. Without that, I really don't see how anybody could do it. or it'd be extremely time consuming. This question is already time consuming even with the divisibility rule, as you will soon see. Okay, so let's first concentrate on this guy right here. The number is even, so that means all of these guys have to be even. If that is even, that means that A has to be either 2, 4, 6, or 8, right? It cannot be 0, right? Because if the A was 0, then if you put a 0 here, you'd have to put a 0 there, and it's no longer a 5-digit number. It'd be a 4-digit number, and this is our range. We have to have 5 digits. So these are our values for A. So all of the numbers are going to be of this form, either 2, blank, 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 2, or 4, 4, and then, blanks in the middle, and so on, of that nature. Okay, so that's the first part, and that helps a little bit. It doesn't solve the question, but it helps. Now, to solve the question, we have to use this guy, this divisibility rule, which is really going to help you. And it's not that difficult, it's just very time-consuming. That's my opinion about this question. And on math contests, you don't have any time. So that's the great challenge. Okay, so let's start with A equal to 2. All right, so if A is 2, then our number is right here. And then, of course, this is B, this is C, and this is B. So my number is 2BCB2, right? 2BCB2. Now we use this divisibility rule, this one right here, that the sum of the digits has got to be divisible by 9. Okay, so that means that 2 plus B plus C plus B plus 2 has got to be divisible by 9. Well, let's just clean this a bit. That's 4 plus 2B plus C, right? And it's got to be a multiple of 9. So it can be either 9, 18, 27, 36, ... Correct? And then we got to see what we get for each of these. Some of them will get something, some of them we won't. And then eventually you realize that you won't be able to get anything more. For example, A, B, C, they all represent digits, right? So the largest digit is 9. So if B and C were both 9s, you'd get what here? 27 plus 4, 31, correct? Yeah. So the largest you can get is 31, so I don't think you'll be able to go past these guys. Got it? Okay, so let's work with this. If 4 plus 2B plus C is 9, that means that 2B plus C is equal to 5. If 4 plus 2B plus C is 18, that means that 2B plus C is equal to 14. And if 2B plus C plus 4 is 27, then 2B plus C is 23. All right, those are the only cases that are possible. And then these ones you just solve with substitution. So for example, what happens if I put B equal to 0? Well, if B is 0, then C is 5. If B is 1, then C is 3. And if B is 2, C is equal to 1. And those are the only positive integer solutions. Got it? Similarly with this guy over here, you will find that you won't be able to get a single digit for C if B is 1 or 2, but you will when B is 3. C becomes 8, I believe. And then similarly, when B is 4, C becomes 6. And then so on. You'll be able to get these pretty quickly. When B is 5, C is 4. When B is 6, C is 2. And when B is 7, C is 0. And very similarly over here, the solutions are when B is 7, C is 9. When B is 8, C is 7. And then when B is 9, C is 5. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 11 solutions. 1A is equal to 2. So I'll just put that here, 11, since this is sort of our master list for the A's. Okay, so now I think you guys are experts on this question, and I am not going to waste any of your time by going through every single one. I'm confident that you can do a equals 4, a equals 6, and a equals 8. And just to help you out a little bit, here is the sort of the way to do it. And so I guess, okay, fine, I'll just show you. When a is 4, same story, right? There's no real difference here. The number is A, B, C, D, A, right? So it's 4, B, C, B, sorry. Not D, it's a B, because it's a palindrome. And then the sum of the digits, and this is a 4. The sum of the digits, 4 plus B plus C plus B plus 4, have to be divisible by 9. So that's what, 8 plus 2B plus C. And again, they can be either 9, 18, 27, 36, dot, dot, dot. But in this case, as we previously mentioned, the only ones that could work are the first 3, I believe. Yeah, because you're never going to get, even with 9s for B and C, the highest you're going to get is 35. So you're never going to get to that 36. So again, if 8 plus 2B plus C is 9, that means 2B plus C is equal to 1. If that is equal to 18, then 2B plus C is equal to 10. And if that is equal to 27, 2B plus C is equal to 19. And that's exactly what they have here. 2B plus C is 1, 2B plus C is 10, 2B plus C is 19, and for each they gave these solutions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the same story for A equals, I think this one here is A equals 6, and then the A equals 8, I'll let you guys do that. And when you add it all up, you'll get the total of 44 total palindromes. So it's a good question. So time consuming, but it's entirely doable if you're very fast. You can crunch out these numbers really quickly. You should be able to get it. So that's the answer, 44. And there's 11 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I guess for A equals 8, there was also 11. So there was 11 for that guy, 11 for this guy, and 11 for this guy. So in total, and there was 11 for A equals 2, if you recall. So 11, 11, 11, 11, 44. That's the answer. Question 25. Arjun has a bag that contains 5 balls, and Becca has a bag that contains 3 balls. Arjun's bag contains 2 red balls, 1 green, 1 yellow, and 1 violet. Becca's bag contains 2 black, 1 orange ball. Arjun randomly chooses 1 ball from his bag and puts it into Becca's bag. Becca then randomly chooses 1 ball from her bag and puts it into Arjun's bag. Arjun randomly chooses 1 ball from his bag and puts it into Becca's bag. After these exchanges, there are 4 balls in each bag. What is the probability that each bag contains exactly 3 different colors of balls? Well, this is one of those questions that involves a lot of, what's the right thing to say? Trial and error, or you have to create a system. Now, the system may involve a lot of trial and error, and I'm not going to do trial and error because you don't want to hear me do all that. So I'm just going to show you the proper pathway. So Arjun initially starts with R, R, G, Y, V, right? Red, red, green, yellow, violet. And Becca has BBO, black, black, and orange. Correct? So this is Arjun. And this is Becca. Got it? Okay. So Arjun moves first. So we have to first do an A to B. Arjun to Becca. So the proper pathway is first you have to move the R. Got it? So we've got to take this R and move it to Becca's bag. Now, the probability of choosing an R from this is 2 out of 5. Okay, so that's the probability of that first move. Then the next move we have to do in order to make this work is remember, our goal is to get each bag having exactly 3 different colors of balls. So our next move is Becca now has to send a ball over to the other side. And the proper move there is, again, the R. So you're just sending the R back. Now, after this move here, the bag here is RGYV, right? Because the R is moved. But on this side, it's RBBO because the red ball is now here. Now you move the R back, and the probability of choosing an R from here is 1 out of 4. Okay, when you move the R back, now we have, again, we're right back to where we started, RRGYV, and here we're right back to where we started, BBO. And now it's time for Arjun to make his final move, and he will send over either a G, a Y, or a V. And the probability of choosing one of those from those 5 is 3 out of 5. So let's say he chose the green to move over. He would be left with RRYV, and Becca would have, sorry, I believe this should be an R, sorry about that. And this will be GBBO. Now, does this final state satisfy what the question is asking? Each person has 3 different colors. There's a red, there's a yellow, there's a violet. That's 3 different colors. There's a green, there's a blue, there's an orange. That's 3 different colors. Okay, done. Now you have to look at the probabilities. And we want all 3 of these to happen. So if all 3 have to happen, you have to multiply them. So 2 over 5 times 1 over 4 times 3 over 5. And that is 6 over 100, which in lowest terms is 3 over 50. Okay. Now, unfortunately, that's not the full story. There's 2 more stories. This was one story. There's 2 more. So I will definitely walk you through the other 2. Don't worry. I'm not gonna. It's a little bit challenging, so I'm gonna do it. But at the end, we have to come back and include that 3 over 50. Okay, second scenario hopefully won't be difficult for you to understand, since we've already done the first scenario. Okay, if we recall, we started with RRGYV, and here was BBO. Now, the first move, which is A to B, this is another pathway that will lead to success, meaning each bag will have 3 different colors. The first move you do in this scenario is you move either the G, the Y, or the V over. Okay, either one. So of these 5, the probability of choosing one of these 3 is 3 out of 5. Okay, so let's just say she moved over. Arjun is a guy, and he moved over, let's say G. So if that's the case, then when we get to the next round, it would be RRYV, and over here would be GBBO. Okay, now it's Becca's turn to send one over to Arjun, and she has to send over a B for this to work out. Okay, so from those 4, the probability of choosing a B is 2 out of 4, since there's 2 B's, so that's 1/2 in lowest terms. Now we have an RRBYV, and here we have a G, a B, and an O, if I'm not mistaken. And now we have the final move, which is A going to B, and for this to work, he now has to move back to B. So he gets RRYV, and Becca gets GBBO. The probability of taking a B from here is 1 out of 5. And let's see, do these satisfy 3 different colors? Red, yellow, violet. Yep. Green, black, and orange. Yep. Okay. So we have to multiply these to figure out the probability of this scenario. So it's 3 out of 5 times 1/2 times 1 over 5. So that's 3 over 50. The same thing that we got last time. Got it? Okay, one more. So now by this point you're an expert, so you could probably do it, but I will do it for you, no problem. So again, if you recall, what it was at RRGYV when we started, and was BBO. Okay, so Arjun makes the first move. So in this scenario, again, similar, that he's going to move either the G, the Y, or the V. Okay, probability of doing that is 3 out of 5. And let's just say for our purposes in terms of demonstration that he chose the G. So this comes down to R, R, Y, and V. And Becca now has a G, a green bulb. Okay, now it's Becca's turn. And she is going to move a G or an O. A G or an O. O was orange, I believe. Okay. Probability of choosing a G or an O from these four is 2 out of 4, which is a half. And let's just say she chose to move the G. So this becomes R, R, G, Y, V, and this knocks down to just BBO. And then the final move, which is Arjun to Becca, he's going to have to move either the Y, the V, or the G. The Y, the G, the Y, or the V. And let's just say he moves the G. So this becomes R, R, Y, V. And then Becca would have a G, BBO. The probability of moving a G, a Y, or a V from those 5 is 3 over 5. And now let's see if this passes the test. Does this have 3 different colors? A red, a yellow, and a violet? Yep. And does this have 3 colors? Green, a black, and an orange? Yes. Okay, so use these probabilities to figure out the probability of this entire scenario. So it's 3 over 5 times 1/2 times 3 over 5, and that is 9 over 50. Okay, so 9 over 50 is what we got here. Remember that number. 3 over 50 and 3 over 50. So we have to add those 3 scenarios. So 3 over 50 plus 3 over 50 plus 9 over 50. Okay, and when you add that, that is 15 over 50. In lowest terms, it'll be 3 over 10. And that is the answer to this challenging and time-consuming question number 25.